Okay, there's two ways to take this when it says factoring rules. You may think, oh, that sounds boring, like a bunch of rules. Or you may be thinking to yourself, and I know there's some of you out there that are actually thinking this. Factoring rules! It's the best, right? And you know it. So don't be afraid to admit that you love factoring. Two things a lot of students forget to do is first step, take out the GCF. On a really tough problem, that's going to help a ton. And the leading coefficient should always be positive. That will just cause trouble if you don't do something like that. So you might have a weird, this seems like a kind of a strange factoring here. I always like to think of this in parentheses even when it's not, and think to myself, is there something I can pull out? Is there some common factor? So I might look at the numbers first. You know, those are three numbers there. We got 7, 14, and 21. The least, or the greatest common factor of those would be 7. And I don't want that leading term to be negative, so I'm going to take out a negative 7. So negative 7. And then look at the x's. So now when you look at x's, you've got x to the 4th, x to the 1st, and x to the 1st. I've got at least one x in all of those, so I'm going to take out an x. And then look at the y's. You've got y squared, y to the 3rd, and y to the 4th. I've got at least two y's, so I'm going to take out y squared. So what's left over when you take those out is you have to think you're almost like dividing this by each term in a sense. You're dividing it out of each term and pulling it out. So there's 4 x's on top, 1 on the bottom, so there would be x to the 3rd. Y squared of y squared is 1. So really that times x to the 3rd is that. So we're okay with that term. This is a positive term. I pulled out a negative, so I want to take out, I want to have a negative 2 there. You could say minus 2. That might be better. X divided by x is 1, y to the 3rd divided by y to the 2nd is y to the 1st, so there's 1y. This is positive, that's negative, so I'm going to pull out a negative here. So 21 divided by 7 is 3, x divided by x is 1, y to the 4th divided by y squared is y squared. And I have factored that. I mean, that's considered factoring. If you can take out a GCF of every term, that's a greatest common factor. I have factored this. Sometimes there's additional factoring to be done here. I don't think there is in this case, but many times there'll be additional factoring that you can do. Not a problem. Here we go. I just want you to see this. It's kind of a neat use of this. So if you think of this in kind of a weird way, like one big thing here, almost think of this, I guess kind of like this is the first term, this is the second term. Do you see a common factor with both? And it's kind of an uncommon one. It's x minus 4 is common to both terms. X times x minus 4 and 2 times x minus 4. So in this kind of problem, I just want you to see this, what we're going to do in just a little while here, is so I'm pulling out an x minus 4. So it's kind of like that's my GCF I pulled out here. And inside left over, I'm multiplying by x, so there's an x. Multiplying by plus 2, so there's a plus 2. And I've kind of factored that in a way. So I just wanted you to see that. You don't have to draw that kind of parentheses there, but that's the idea of that one. Okay, so when its leading coefficient is 1, that's kind of the typical form. So what we're saying is that leading coefficient is really 1. If that's the case, this is pretty straightforward factoring. Most students will do kind of a guess and check here kind of thing. So they'll, put parentheses. Okay, this is kind of your classic trinomial x, and x is going to be first times first. That makes x squared. This last two, last times last, will multiply to make negative 6. So off to the side, I'm thinking to myself, I don't always write this out, but I'm thinking, what multiplies to make 6? So like 1 and 6, or 2 and 3. Those are pairs, and obviously one of them is negative, one of them is positive, right? I don't know if it's, so I'll kind of put both pairs up there just so you can see everything. I don't always write this out. So maybe the negative is the 1, maybe the 6 is negative, maybe the 2 is negative, maybe the 3 is negative. Those are all the possibilities. And so we have to multiply to make negative 6, and we have to add to make 5. So which of these two add to make 5? That doesn't add to make 5, that makes negative 5, that makes 1. If I add those, it makes 5, so I'm going to put minus 1 and plus 6. And I have factored that guy I'm using kind of a guess and check strategy. It's also really helpful to think about the signs. I know you've probably seen this before. But when the plus and plus inside the trinomial there, then you know right off the bat, like not only do you know x and x in that case, but this has to be plus and this has to be plus. Just like on this one, we saw the minus there, so we knew one of them had to be negative and one of them had to be positive. So now we're just thinking of positive factors of 12. 12 and 1, that doesn't add to 7. 3 and 4, that does add to 7, so it would be 3 and 4. And then this one, let's think about the signs. So if we're doing signs on this one, it's going to be x and x. Some students like to just go ahead and, just like we knew that, they'll actually put a minus in and a plus in, because they know one of them is plus, one of them is minus. Thinking factors of 15 that add to 2. 15 and 1 doesn't add to 2, but 5 and 3 could. So if I want that, that's positive there, so the bigger number needs to be positive. So the 5 would be positive and the 3 would be negative. And one last one, so if we get something like this, we get x and x. Factors of 8 add to 9. 4 and 2 do not add up to 9, but 8 and 1 do. And if you think about the factors here, this is kind of interesting. When the first one's negative, and the second thing here is positive, we know that these signs have to match, either minus, minus, or plus, plus, but because that's negative, it has to be minus, minus. Let's see if that works. You can always double check yourself. Positive 8, negative 8x minus x is negative 9x, so that works. So double check yourself. It's a good thing to do there. Different squares is all over the place in factoring. You got to get used to that in Algebra 2. This is just a very straightforward problem of that. I think you're getting that. We did that the other day. So this will be, if you might want to write it. Some people rewrite that. They'll actually write that as 5 squared so they can see the form of it. B squared is 5 squared, so B is 5. There's not 25. B squared is 25, but B is 5. So this would be x and x. And according to the form, one of them is plus, one of them is minus. And B is 5, so it'd be 5 and 5. You could double check yourself, multiply that out. You'll notice something interesting happens. 5x minus 5x, the inside-outside part of that, when you multiply, just kind of goes away, which is going to happen every time with different squares. So that's handy. Okay, let's look at this one. So it is kind of difference of squares if you think about it, because 4 is a perfect square, x squared is a perfect square, and y squared is a perfect square. So it's just a little bit harder as far as fitting the form here, but I think we can get this to work. So we've got, according to the form, it's going to be x and x, and one of those plus, one of those minus. And this will be the square root of all of that is b, because b squared is that term right there. So that's b squared. So this will be 2y and 2y. And here's another one. And this one doesn't look like difference of squares at first, actually. But if you remember, I told you it's going to really help to think about the GCF first. So if you take out a GCF, the GCF of that guy is, well, I know 2 is. So 2 times 9x squared minus 25. Now see if you can factor that any further. Does that factor at all right there? And hopefully you recognize it. 9 is a perfect square, 3 squared. X squared is a perfect square, and 5 squared is 25. So this would be 3x plus 5 and 3x minus 5. That will become an easier problem the more of those that we do. There's one more. Try that one. See if you can factor it. A lot of students try this. They go, oh, difference of squares. They go x, 3, x, and 3. And they go minus and plus. Wait, that doesn't make that positive. So then they might try minus and minus. That gives me negative 6x when I multiply. You might try positive and positive. But when you do inside outside, you get 3x plus 3x, which is 6x, which is not in there. You cannot factor. So some things are going to come to you and you just go, cannot factor. And there's no answer. There's no simplified form of that. So not everything will factor. Sum and difference of cubes are, you need to memorize these formulas for the quiz and for the test for sure. This fits the form. If you can see 8, if I rewrote it another way, would be prime factorization is 2 to the third power. So it does fit the form. A is x and b is 2 there. So according to the form, this will factor to be x plus 2. That's a plus b. A squared would be x squared. Minus a times b, which is x times 2, or 2x. Plus b squared, which b is 2, so that would be 4. And if you don't know difference of cubes, it's going to be, or sum of cubes, in this case, it's going to be very difficult to factor this. So I strongly recommend recognizing, and anytime you see third power, I want you to be thinking, maybe it's sum or difference of cubes. So this is the sum of cubes formula. Memorize that if you know it. This is the, let's see, we have the difference formula. So difference formula is the same except for one little thing here. So it's the same formula. Let me write this down. So difference formula would be a cubed minus b cubed equals a minus b. So it starts with a, instead of a plus, has a minus there. Then a squared plus ab plus b squared. So that's the difference of squares. And this is the difference in the formula. This and this and this. Those are different from the sum formula. And so if you got something like this, we should be able to do that. That's really 3 to the third. That's 5 to the third. Uh-oh. Something's wrong. I need to factor out first. Let's take out the x squared first. So x squared, I'm going to write this as 3 to the third. That might make more sense. X to the third minus 5 to the third. Something like that. Just so you guys kind of see the form that a is really 3x and b is really 5. And so I still, when I factor this, I still have the x squared out front. Don't forget about that guy. He's a GCF. He's out front. Then I just do a minus b. So this would be 3x minus 5 times a squared would be 9x squared. 3x times 5 is 15x, so that would be plus 15x. And b squared would be 25, so plus 25. And very tough to factor if you don't know those formulas. So I strongly recommend memorizing those guys. Last thing, factoring by grouping. So when you have 4 terms, there's only one method available to you. You need to group the first 2 terms. So this would be like 6x cubed. If the first 2 don't work, sometimes you have to regroup. Minus 9x squared. I always like a plus sign to be in between. So I'm going to group that. Negative's going to be inside of there. Negative 2xy plus 3y. So once you've grouped them, you want to pull out the GCF of each term. So pull out the GCF, pull out the GCF, and let's see what happens here. So we get, that would be 3x squared times 2x minus 3 plus, pull out the GCF. In this case, I want to pull out the negative also. So I see a y and I see a negative, so I'm going to pull out negative y. So negative y times 2x. That's a plus. I pulled out a negative, so it would be minus 3. I pulled out a y. And then kind of like we were talking about at the beginning of the lesson, I told you it might come in handy to see that there's a common factor there. So really one of the factors is 2x minus 3. And the other factor, which is being multiplied by that, is the rest of this guy. So the rest of that would be 3x squared minus y. And so we factor something with 4 terms. And that's called factoring by grouping. It's a very powerful method. Anytime you see 4 terms, I want you to think to yourself, okay, factoring by grouping. Let's group 2 of the terms. If the first 2 don't work out and the second 2 don't work out, maybe you could try grouping the first and third terms and the second and fourth terms. Try grouping a different way, and sometimes that will be the secret to getting it to work out.